Everybody, welcome to Cassandra Lunch number 14. This week, we're going to be covering how to diagnose Cassandra issues. We'll do a little bit of hands-on if I can get the interface up and running for Kibana, but we'll talk about it. And some of the team members from our company, this is a repeat, but when the data comes up, we'll be able to kind of hopefully see what's the process to go through and look for data to show a particular problem that's going on. All right. Our co-organizers are myself and Akwi. Welcome you guys to come help. Email akwi@anant.us. We are an inclusive community, always looking for underrepresented folks to come and speak about different things in data, because the data community is part of a much larger community of groups. We cover anything to do with DataStax, Cassandra, things that work with Cassandra, such as Spark, Kafka, Flink, different variants of Cassandra. If there are any new people, give them an opportunity to make an introduction. Looks like we have regulars today. If you have a question, ask it, be polite, or you can ask in the channel, chat channel. As part of the Zoom. DataStax is a big supporter of this group, as is GW, as are a few companies in Chicago and DC area. Our institutional sponsors support the whole nonprofit of Data Community DC, which helps make up for shortfalls of each group. See any announcements? Any announcements from the group today about events coming up? I know there are a few events coming up in next week. Here, I'll bring it up on Eventbrite. So we do have a webinar coming up for Spark and Cassandra for machine learning, specifically cross-validation, which is part of a series. There's another event on just Spark and Cassandra. There's another one on Terraform and Kubernetes on AWS, and then running Cassandra on Kubernetes with Terraform. So cool stuff. All right, I sorry about this. You go ahead and bring up the presentation again. Okay, so today, what I wanted to speak about is diagnosing Cassandra issues. So Cassandra is a distributed system, and it's hard to understand what's going on because there's so many different computers. And so, what we're going to talk about today is the general tools that are used. And then if we have time, we'll zoom into one of them. So to start with, there are some resources that we have collected on our website. If you Google, Cassandra, Solar, Spark monitoring. Oh, wow, we're number one. Well, that was a very specific search. So, talking about why do we need to monitor these systems in the first place, right? And the reality is that if we're running a system that's distributed, we are running it for performance reasons because one computer just couldn't take the load. there's a reality of why we use it is because it's a performance need. So if we're trying to squeeze out the most out of the computing power or the network and the CPU, the memory, the disk, then it behooves us to actually measure that so that we can see how much hardware we need now versus how much hardware we need later, right? And there's different types of monitoring. Of course, we're going to talk a little bit about Cassandra, but there are endpoint metrics, which are when a user hits the system, how long it takes for them upon initial request. There's logging in software itself, and this is not stuff that a user would see. And these metrics aren't something that a user would see either. It's just that we measure when a user hits it. Logging is all internal. And these are messages versus metrics or numbers. Sometimes we also trace. Tracing means that some transaction is happening and we want to see exactly what happened in every step of that transaction. Different software have a way to trace, and in databases, specifically Cassandra, have a way to trace queries. Especially in Cassandra, that query may be going to several machines and getting that information and bringing it back. System metrics. System metrics are the pure hardware and operating system. We want to measure that because maybe we can isolate that nothing is wrong with Cassandra. That maybe we're hitting a CPU limit or a memory limit, or a disk is too slow. Some applications have performance metrics specific to that application. So this could be a custom application, it could be Cassandra, it could be Spark. In Cassandra, we can measure latency and throughput based on some data that's available via GMX, and there are tools to help aggregate that data and store it somewhere. And then there are application-specific metrics, not related to throughput or latency, but for example, if there's an application that does e-commerce transactions, then it could measure the number of dollars that have come in the last hour. That generally goes to the world of business intelligence. There are other, let's say, application-specific metrics, such as like if your application is doing a special type of transaction, how many times is that transaction happening? So inside the e-commerce system, orders, shipments. Between an order and a shipment, there may be another transaction between the shop, the e-commerce shop, as well as the distribution center or the wholesaler, right? So most businesses, at least that I've worked with, they end up using some sort of log aggregation software at the top, meaning if you have a distributed system, you have to do log aggregation at some point. Some of the commercial ones are Splunk, SumoLogic, Ematext, Datadog, New Relic. They are all different tools. They all have more than log aggregation. They do other things as well. There are open technologies such as ELK or BEK, Beats, Elastic, and Kibana. There is ELG, such as basically Elastic, Logstash, and Grafana. Grafana has a different user interface. Graylog, which is a combination. It actually uses Elasticsearch under the hood. It's different. It's a little bit more set up and structured so that you don't have to do your own setup and structuring of certain settings. And recently, because of cloud native, Prometheus and Grafana have become, especially Prometheus is a successor to Graphite, but Prometheus and Grafana are the standard in terms of measuring what is happening inside each container and being able to visualize that. If you've seen DataStax's Astra application, their metrics board, their dashboard, is actually a Grafana embedded in their application. Before we go forward, are there any questions about just different types of monitoring and the purposes of monitoring it? Okay. I'm going to show a deck, and then I'm going to go back to this blog post. And the reason I want to show this deck is that it illustrates visually the need for at least log aggregation, but we can also envision different type of metrics that we may need to collect, let's say for Cassandra. So I'm not going to go through the whole thing, but essentially the reason we need logs, and we're going to look at logs a little bit later, the reason we need logs is that even if a system is working smoothly for the most part, if there are errors, we don't know about them, then we'll never know down the line why a failure happened. So warnings, debug statements, even info statements in the log help us see what is about to happen. So it can be used for preventative maintenance, basically to intercept a potential issue that's coming up. Here's a cloud application. It's actually the architecture for cloudskew.com. I'm not even sure what that is. Oh, it's a tool for diagramming. So they've basically shown how they have made their application. That's pretty cool. Companies are complex business platforms with systems creating data all the time. And there's data that is pertinent to a business, but then there are applications that manage that data that are also creating data. And having that log and metric information helps us keep the system up and running. It's like having, like an Apple Watch measures your heart rate and how many steps you're doing. Logs and metrics are kind of like that for each computer or each application. And in Cassandra world, like this, we're talking about each data center, each node in each data center around the world, having visibility into how that's running. And if we use Kafka and Spark, or akka is another distributed application framework, we can get visibility on each of those machines. There's another architecture where there's 3 data centers. In this process, in our code that is ingesting data into this queue, we may also log that successfully retrieved this message, or I had an issue, I had an error with this message. So that down the line in this process, if we have to check to see if all the messages came through, we can say, well, you know what? Every message that came through here made it to all the different data centers. But that doesn't necessarily mean that every message that came from here made it over here in the first place. So to diagnose issues in a distributed system, especially like a message oriented system like this, then it'll be very hard to figure out where something went wrong. The only way to resolve it would be, well, I've got a message that got dropped, so I need to send that message over and over again. Not really realizing what's going on that's preventing that message from going through. In Cassandra, the whole system is built on messages. The whole system is built on something called SEDA, Staged Event Distributed Architecture. And there's a specific one for even Cassandra. Here we go. There's one picture about setup where messages come into one process, they get sent into another process, they get sent into another process, and then these can send messages back and forth. And then looking at Cassandra, client request comes from node 1, sends a message over to node 2, which reads, sends a message to request response, to node 1, and then node 1 sends it back to the client. So the whole system is based on messages being moved around between different systems. And then those messages are processed. So when a write request comes in, it goes to the write stage, and then it writes data to the mem table and basically says, I got it. It also writes it to the commit log. And then later, other events get fired up for, let's say, compaction, right? But they don't interfere with the write process, for example. Lots of different variations of this diagram, but I'm not going to go too much into this. So what's a major challenge? Well, it's everywhere. The data is everywhere. It sits everywhere, right? So what do we need to do? We need to get that into one place. Elasticsearch is one of those tools that is freely available and commonly used for log aggregation. And there's different ways to get data in there. Logstash, Beats is another one. Beats can also send to Logstash, and Logstash can send to Elasticsearch. Some people have Beats sending data to Kafka, it buffers it, and then it sends it to Logstash to Elasticsearch. And then Kibana is a front-end tool that we use to look at that information. In this case, Logstash is running as a server, and different things are sending data over the socket directly. The application is directly sending it over TCP/IP, whatever needs to be measured. It goes into Elasticsearch, and then we can visualize it in Kibana. And Kibana is not the only thing that can take a look at Elasticsearch, right? Grafana is another tool. So we get our stuff together. How do we do this? Well, there's two main ways. Approach one is before the fact, you set up the tools to monitor stuff. Approach two is you do it after the fact. You get the data later, and then you ingest it. And I'm going to show kind of how to look at this information after the fact. There's a toolkit. If you're willing to take a look, it's Cassandra. I think if you look at the Cassandra toolkit, it should come up. There we go. The Cassandra toolkit gives you some curated videos, curated tools. We'll add videos to there later, that we've vetted. Some of these tools we've made, other tools other people have made. But if you're interested in learning how to set up a monitoring system that uses Prometheus and Grafana and ELK stack on top of an existing Cassandra cluster or a Dockerized Cassandra cluster, take a look here. Also here are some tools that we've made. There's a tool called Node Analyzer, and Node Analyzer basically is a really, really simple tool that we give some of our clients to collect data from that machine. So what does this script do? This script basically gets the logs, and it runs a particular, we'll end the configuration, but it runs a series of no tool commands that we specify in commands.txt. So this is, I would say, my minimum list of commands that we need some information. So as you can see, we can run status, tells us if all the servers are up, or they look like the whole system. From my perspective, if I'm on one node, if I say no tool status and all the nodes are up, then I know that I can see all the nodes. That doesn't necessarily mean another node can see me. So we have to run it on all the nodes. Describe cluster gives us some information about the gossip, which info gives that information. CF stats, there's in newer version, it's called table stats, although I think this still works. TP stats are thread pool stats. This is specifically statistics about those different thread pools. Compaction history, recently, what's been compacted, how much data has been compacted. Compaction stats are related to the threads, but the history shows actual partitions being compacted almost, and necklace tables being compacted, whereas compaction stats just gives us in summary form. Compaction throughput shows us how much data has been compacted in a certain time frame. Excuse me, this is the setting. What is the throughput that we've set? And we can also get that. What is the setting? Stream throughput, same thing, it's a setting. Proxy histograms show us essentially histograms of metrics from like 99th percentile. How is it? And the version is just what version are we running, right? So this tool, Node Analyzer, will go get that data and put it conveniently into one zip file. So we have to write it on each machine. And our team members are working to make this a little bit more automated. The other tool that we have here is called Table Analyzer. We'll do a demonstration of this at another time, but Table Analyzer takes specifically the output of CF stats from each machine and helps us visualize skew. And CF stats has about, oh my gosh, 20 different metrics. Actually, we can see. Yeah, roughly about 20, 25 different metrics that we want to measure from each machine. So we run it, we do okay, but sometimes we want to see this data change over time. We have to use different tools for that. This tool is just for snapshot. I want to see what's going on. And I'll show a demonstration of some of the log analysis today, which is to go to the dev branch, which is where we set up Elastic, FileBeat, and Kibana using Ansible, and then we have a script that can take basically a big tar-gz ball of data and untar it and automatically ingest it. Now, right now, it just does off-center tarballs, but we're working on taking the output of this node analyzer and having that also automatically be, sorry, wrong one. Have it automatically be ingested. The cool part about this is that all you need to do is say, run this script. Here's my tar-gz and my client, meaning like whatever project I'm working on, clean out FileBeat, and it'll automatically just put everything into Elasticsearch, and then we can go visualize it into Kibana. So I'm not going to run that today, but what I am going to do is to show, having some data, how do we start to see what happened? So we ingested some data, and we see that between, let's say, July 9th and July 17th, and we could probably even say, let's say, last 90 days. Right? Everything that we have is really between those dates. We got an offline dump as we looked at it. And this shows us some picture. And the picture says a bunch of stuff happened, and then nothing happened, and then a bunch of stuff happened. This doesn't necessarily tell us if something bad happened or something good happened. It just tells you that something happened. Another is that it doesn't tell us where it happened. This is from the whole cluster, right? If we were to say, sorry, I'm going to filter just one of the host names, if it will allow me to do that. And I'm just going to pick one of the host names here. Did I do this correctly? There's a better way to see basically where the messages are coming from, and I'll go there in a second. But this is raw data. I can just look for things like error. What this will show us, hopefully, is during this time frame, when did the errors happen? You know what? Not a lot of errors. Compared to the 12 million hits, we only have 632. So we have some hits here. And at least we know that there were some restarts that we did. So that accounts for why those errors could have happened. Okay. We can always look deeper to say what happened. Oh, cannot proceed on repair because the neighbor is dead. That's a problem. But in Cassandra, it's not that big of a problem because data is replicated to different machines. Okay. Let's see if there's warnings. Okay, so warnings, a bunch of warnings over here. Okay, what are the warnings? Not marking nose down due to local pause. Not marking, okay, gossip tasks. Okay, so what this is saying is that when a particular node went down, a bunch of warnings came up. One is something called a gossip age mismatch. Another one is, I think that's a lot of them are basically gossip stage. Oh, compacting large partitions is another one. That's something to take a look at. Large partitions can be a problem, right? So having this data in Elasticsearch, just being able to search it and see how many hits are happening is a game changer. If you didn't have this, right, this is for, I think, 12 nodes. If you didn't have this, even with 3 machines, trying to find out what's happening, it would be a nightmare. I mean, you would basically go to each machine and you'd say, grep this file and this file and this file, right? In this case, we've ingested everything. Garbage collection log, system log. If we wanted to put the operating system's message log, we could have a cron job that dumps, IO stats to a file, and that could be automatically ingested. So having all that correlated in one place is a game changer. If we didn't have that, when I say correlated, we have not done the correlation, but Elasticsearch has correlated all those events by time. That's the game changer. It has done one level of correlation for us. Okay. Now, other things that we can do in Elasticsearch are visualization. The machine learning is interesting, but I don't necessarily think it's machine learning. It's running a bunch of existing models and understanding. Let's see. I believe I have. No, I don't have it. But we'll come back to this. There's another data visualizer, which is, but machine learning, what it does is just kind of gives you some basic histograms and occurrences, and I don't think it's anything special. Everybody wants to say they do machine learning, whatever. So this doesn't have something called, timeline. So I'm going to make a timeline. And there's so many different visualizations I can do off of that data. As long as I've parsed it, I can look at it in different ways with summations and counts and normally what you do in SQL and a BI tool, you can do in here. If we don't have something extracted or parsed exactly as a number or whatever, or a date, we can do something called a scripted field after the fact. I'm not going to get into that today, but we can extract, for example, dropped hints. If we didn't parse it, we can look for the term dropped hints with a regular expression, and it will actually show us across the index every time that's come up. And the number, not just that the words dropped hints occurred, but rather what is the number that came out. And we can do counts, or sorry, we can do summations and aggregations on that number across different machines. So we can see, well, 50 dropped hints here, 100 dropped hints here, so together we're 150 dropped hints at that particular time. So timeline is my favorite one. I'm still learning it. There's much more powerful tools like Splunk that can do much better things with a better syntax. But what I like about timeline is that once you get the hang of it, it's pretty easy. So this just is find everything in Elasticsearch that I have across all indexes. Now, right now I only have one index, so that's fine. Right? But what I can also put here is to say split this based on host name 12 times across 12 buckets. And what this is showing us is, okay, well, there's only 6, so I'll just make this 6 now. So there's 6 machines, and we have, right now, these are just log entries. They're not even errors or anything, right? So what we can now do is to say, show us the warn across those 6 machines. And we can see that there's pretty much only one computer where the warnings are coming from, right? It's this green one. Okay? So if we have to look deeper, we basically know where to look, right? We're looking at this machine. Another visualization, I didn't save that one. It's called Lens. And Lens is kind of like a BI tool. I think another one is too, but I like this one better. So what I'll do is I'll say, I want basically, and I can search, by the way, I can say, like error, right, or whatever. But let's just say I want to look at all messages across machines. And I'm going to say timestamp because it'll help us basically see across time what's happening. Right, so that's the y-axis. And this is just doing a count of records. By default, it just does that. But I can drag over host name. I do not want to do count. And still it's doing a count, and I don't want to count. What I just want is count of records. Yeah. Oops. Oh, sorry. This right back. Breakdown by host name. So that's interesting, right? I get counts, but I can get that same information by host name. I can also say do it by the component name, because we know Cassandra is made up of all of these components that send messages between each other. Let's see which ones are creating the most messages. So anti-entropy stage is the repair process. Memtable plus writer takes mem table, writes it to SS tables. Compaction executor, right? So what we can see is that not a lot of messages getting created. Repair job. So anti-entropy and repair jobs are related. Okay, there's anti-entropy sessions, really low number here. So the majority of the messages that we're getting are really due to repair processes. And this seems to be a manual repair process. They run a repair and then they stop and they wait and they run another repair. So looking at this, I've gotten some insight into their operations already. Okay, but I still don't know what the problem is. So going back to my timeline, I'm going to do some queries that normally you wouldn't find in Cassandra logs, but because we've ingested the system logs themselves, we can look for it. So let's look for killed. Okay. Killed is a message that the messages log will tell us that some process was killed. Okay, no process was killed. Okay, that's good. Let's see if there are memory issues. Oh, shoot, some memory issues. Okay, let's split it by host name. And same machine. So something is happening with memory on this machine. So we know we have to look in that machine. And what I can do now is go back to Discover. I've identified that there's one problem computer. It's given the most warnings. It has a memory issue. And let's see if I can get this exact. There we go. So it basically sees if that particular one exists, but I want to change this to if it is. There we go. That's what I was trying to do earlier. And I'm going to get rid of this query. I just want to see everything that's happening on that machine, right? So that machine across time, there weren't that many warnings, but there were a bunch of messages here. Okay, so let's zoom into this machine just at that time. What is happening here? So something happened here, right? Everything is fine, but then something happened right here. Zoom in. Okay, so everything is fine. Everything is fine. What kind of messages are these? These are repair messages, right? And something happens right here. Special. Something special happens right here. Okay, so this is doing some compaction, some repair. This is doing repair. Okay, all right. And then what happens here? And it seems like, again, it's repair. Yeah, repair tasks. And if I run a warn, no warning, I'm going to back up a little bit. And I'm going to extend this a little bit. Nope, no warning. How about some error? Nope. So I've zoomed in. I didn't find what I was looking for. So I've got to zoom back out. And I've got to look for something else. I've got to look in a different time segment. And what this has taught me as I do this stuff is that maybe I don't want to look for warn, maybe I want to look for error. Okay, no error. How about the word dead? Because it said some stuff was dying. Okay, nothing is dead. Memory. Nothing related to memory. So I'm going to go out on it and try to go back in time to say, when did the warnings happen, right? I'm going to keep extending that time window. Okay, so we found 6 warnings during this time. And the warnings are basically related to the large partitions. Let's see how big these partitions are. So that's a 200 megabyte partition. It's a pretty big partition. Some node was temporarily unavailable. Okay. Compaction. Oh, this is, don't worry about this. So compacting a large partition. This is, again, 200 megabytes. And that's about it. I mean, we're looking at all the warnings that happened with that window, right? And there are no errors. Ah, there is an error. Look at that, 100 errors. Some machine is down, basically. Right? And what it could have been is that during that time, one machine was down. This one machine was down. And then it came up. And then those errors went away. Now, let's ask the question, did that error only show up on this one machine? So let's take a look. Let's get rid of this filter. In this window, were there other errors? No. That error only showed up on that one computer. Across the cluster, everything else was fine. So this could be a networking error, right? The network was disconnected for a little bit of time. So I'm going to pause there because we can always dig deeper into this analysis and try to go deeper and deeper. But hopefully you guys understand that this is not a magic tool where you just put data into it and it'll tell you where the problems are. That's not what this is doing for us. What it's doing for us is making the task of investigation easier. And the investigation of a Cassandra platform, the diagnosis of what's causing issues is actually in the, it's almost a data analysis. It's like a forensic data analysis of what's happening. How often does this thing happen? And you know, we're not even looking at CF stats in this one. We're just looking at logs. But if we have the CF stats data, we could see, oh, tombstones are pretty high right here. Oh, the latency is high right here. And having that metric information alongside this, we can say, well, because of these errors, the other nodes started to have a latency because they were kind of doing some extra work or whatever. Okay. Okay, so we're going to come back to the article and finish off. So there are lots of different tools that can get us data. So for Spark, there's a couple of articles on here on how to get data into Grafana. And we'll do that as another session. For Cassandra, again, a bunch of different articles and some videos on how to get that data into Prometheus. So this is not the log data. This is the other metrics data that we could look at across the computers, excuse me. And some of them use InfluxDB, some of them use Graphite, some of them use Prometheus. Grafana is the basically the user interface, which can connect to Elasticsearch, Prometheus, and InfluxDB. I don't think Grafana has as powerful of a toolkit to do the investigation that we did. I think it's more for just monitoring numbers. It may. I don't think I've seen a plugin that does that level of analysis, like timelines based on a search query, for example. Solar has different tools to basically get that data ending up in the same place, Prometheus and Grafana. So generally, you know, if you have to look at Cassandra, your starting points are going to be, well, what do you have in place? Right? What do you have in place? Do you have the Prometheus exporter from Cassandra? Do you have the FileBeat picking up the logs and sending it to Elasticsearch? If not, then we have to do the second approach, which is give us your tarballs at least, and we can look deeper into that. So, you know, how to get good at this stuff? Start with the logs. Logs are the more detailed information. The metrics information is useful to see trends, and it's really much more useful in real time. Although logs can be useful in real time, I think you have to have them for offline analysis. So, you know, you can learn how to install Elastic and Kibana. You can learn how to use hosted Kibana, like on AWS or Elastic. You can learn about different logging formats. So Cassandra has a few that we use. It has a garbage collection log, and it has a Cassandra system log. Logstash is another tool. We use FileBeat in this toolkit. But FileBeat and Logstash are analogous to each other, although Logstash is an older technology built on Ruby/JRuby. It's still used because it has a server interface that FileBeat could send data to it, and it pulls that data, and then it sends it over. I prefer FileBeat because it's written in Go. The whole Beats ecosystem is written in Go. And we find information, filter it in Kibana. You can also look at stuff in Grafana. So the answer for how to do Diagnostics in Cassandra is learn how to use Elastic and Kibana. Learn how to use Prometheus and Grafana. That's how you can diagnose issues in Cassandra. Better, faster, more quickly, as the cluster begins to grow beyond 1 computer to 3 computers to 30 computers. Kibana has changed over the years. We just looked at a few of these interfaces when we were taking a look at it, but it's a very powerful technology. Any questions? I know some of you guys are working on diagnosis tasks, so if you have questions, you know, you can ask them now, and we can get. Don't mention any customer names. Just the general case and what we're trying to do. Okay. All right. Well, thanks everybody for joining. We'll see you next week, same time, same place. And until then, have a great week.